This is part 3 of section 8.5. We want to find the value of this annuity. We have periodic deposits of $1,200 at the end of every 3 months. So the p-value is 1,200 at 3.5% compounded quarterly. So our rate is 0.0325. Quarterly is 4 times a year, so our end value is 4. Time is 6. Now we plug into our formula, and the value will be 1,200 times 1 plus r over n raised to the n times t minus 1. And all of this is over r over n, so 0.0325 over 4. Now I'm going to assume by now that you have some experience and you're kind of following along how I enter things in the calculator. So in the interest of time, I'm just going to tell you that magically I went to my calculator and your A value is approximately $31,658. So that's the value of the annuity. Now to find out how much is in interest, we need to figure out how much was deposited. And that will be $1,200 every 3 months, so 4 times a year for 6 years. Multiply this all together and you get $28,800. Now to find out the amount of interest, you subtract 31,658 minus 28,800, and the interest earned is $2,858. Okay. So, next problem. So we have 2 choices as to how we can invest some money. We can invest a lump sum deposit of $40,000 at 6.5% compounded annually. Or we can deposit $1,600 at the end of each year at 6.5% compounded annually. See, we have the same rate, and both of these will end up investing $40,000. That's how much you'll end up depositing here as well once you calculate the number of times you've deposited and how long you are. So after 25 years, how much more will you have from the lump sum investment than from the annuity? So for the lump sum, that means we're not depositing every time. This is the formula we need from the previous section. The future value for compound interest, we've had one major investment, and so we can figure out the rest. So for the first one, for the lump sum, that's option 1. Our p-value is 40,000. Because this is principal, times 1 plus the rate over the number of times, it's annually. So this is going to be 0.65 over 1, and I'm going to leave off the 1. Maybe I should. Our time is going to be 25 years for both of them. The rate is 0.065 for both of them, and n is 1 for both of them. So I have 1 plus the rate over n, so this is just going to be 0.065, raised to the n times t. 1 times 25 is just 25. So if I do 1.065, raise that to the 25th power, and multiply by 40,000, I get that it's just over 193,000, and we're supposed to round up, so that's going to become an 8 there. So from the lump sum investment, $193,108. Okay. Now let's look for option 2. This one, we have equal payments over a certain amount of time. So this time our p-value, here it was the whole principal. Now it's the amount of payments we have, the amount that we're depositing in each period. So in this time, our p-value is 1600. And we have 1 plus r over n, which is still 0.065, raised to the nt, so it's 25 times 1. Then subtract 1. And you're dividing by r over n, which is 0.065. This one's easier than some of our others to enter in the calculator, but you get $94,220 once you type it in. Okay, and we're asked how much more do you have from the lump sum than the annuity? So what we're being asked to do is just to subtract these. So how much more did you get? You get $98,880 more.